So this week we've been graphing systems, and we've been talking about the solutions, right? And where is the solution located when you graph a system of equations? It's where they cross, right? It's a point. So we can graph a system of equations and find out what the point is, what the solution is, but we can also then go back and check that, and that's what we call verify the solution algebraically. So if we're given something like this, (6x minus 3y equals negative 15) and 2x plus y equals negative 3. So we could graph those. It would take a little work because we would have to get them in y equals mx plus b, and then graph both of them, and we'd be able to see where they cross, right? That would be what the solution is. So pretend we graphed these, and it looks like our solution is at the point 2, 1. We're pretending we graphed it. This is where our two lines crossed, right? So now what we want to do is verify this solution algebraically. We want to show using algebra that that this really is the solution. So this is a point where our x value is negative 2 and our y value equals 1, right? So what you're going to do is you're going to substitute those numbers into each equation. So substitute those values into each equation. So I'm just going to start with the first one. So it's going to be 6. Instead of the x, I'm going to put a negative 2 minus 3. In place of the y, I'm going to put a 1. It's negative 15. So what we're going to, once we plug those in, what we're going to do is we're going to simplify everything, both sides. This time it's just simplifying the stuff on the left, and see if what we have is a true statement. So we have to do all of our multiplication first, right? So 6 times negative 2 is negative 12. Minus 3. Then a negative 12 and a negative 3 is negative 15. We don't have to do anything on the right, just bring it down. Now, is that a true statement? Is negative 15 equal to negative 15? Okay. So it checks in the first solution. In the first equation. So it is a solution to the first equation. In order for it to be a solution to the system, it has to be a solution to both equations. So now what I want you to do is I want you to go in and do the work to check the second one. So plug in your values and simplify. And see if we get the same thing. Let's look at the first equation. So, Rhonda, what happens to those two negatives?
Cancel each other out.
Yeah, they don't really cancel each other out. They change to positive. Okay. I know what you meant, but I want you to use the correct terminology. Okay, then, William, what's 4 plus 2? 6. So, Mackenzie, is that a solution? No. See, these are not the same. So that is not a solution. Okay. So technically that's enough information. Once it's not a solution to one of the equations, it's not a solution to any of them, to the system. But let's just check the next one. So I'm going to multiply here. 2 times negative 4 is what, everyone? Negative 8. And then negative 8 plus 2 is negative 6. Is that a solution? No. So in this case, when we plugged in the point, it was not a solution to either one of the equations. How did I get negative 8? 2 times negative 4. Okay, now sometimes when you do this, it will be a solution to maybe the first equation you try, but not the second one. In order for it to be a solution to the system, it must be a solution to both equations. Okay, so you have to get a yes or a check. It's a solution to both of them. Okay, does that make sense? So once you check like your first equation and it says yes, you're not done. You have to go and check the second one. Now, however, if you check your first equation and it says not a solution, then you can be done. You don't have to check the second one like we did here. Okay? Because once you get a no, then it's a no for the whole system. Okay. So let's look at this one. What was I going to do? Negative 3x plus y equals 10. And 7x plus y equals 20. So here, the directions are graph, fine, and then check solution algebraically. So are these in a good format to graph them? Not really, right? So before we start to graph them, let's get them in a better format. So the first one, we have negative 3x plus y equals 10. So I want to get that into y equals. So what do I need to move? Move that negative 3x to the other side. Okay. So I'm going to get y equals 3x plus 10, right? Okay, so now go to number 1 on your graph paper and just cross off the number 1 and put example 1. And let's graph this. So where do I go first? to positive 10. So that's your B. That's where you're starting, right? And then your slope is 3 over 1, which means go up 3 to the right 1. We're a little off the graph, but I think we can do this. Up 3, 1, 2, 3, and then over 1. So kind of like we're just adding another line to the graph there. And I want to get some backwards. So go do the opposite. Go down 3 to the left 1. Now that's probably enough. And then we'll connect those. If you want a ruler, you can grab one. If you feel you can draw a straight enough line, you can do that. I like to use a ruler because, huh?
You can't draw straight lines.
I can't draw straight lines either. That's why I use a ruler. Okay. Should we start with the next one now? Okay. So, I'm going to do this one in orange, and then I'm going to graph it in orange. 7x plus y equals 20. Oh, this one isn't going to work. Okay, so then it's going to be, we're going to run into an issue. Negative 7x. So y equals negative 7x plus 20. Okay. Oh, they're in the top drawer closest to me. Okay. So I've just run into an issue, right? Because our graph paper isn't big enough. What could we do? We have to go to 20. And 20, I mean, we can't even get 20 on our graph.
I was going to say divide, but not.
This is the only graph paper I have to use. So what, any ideas? I kind of need to scrap this. Go count by twos. Okay? So let's just,
So you're saying
we're going to redo this, and we're going to count these 2, 4, 6, and so on. So let's go with the orange one first. So y equals
20.
negative 7x plus 20. So we're going to count by twos and go up to positive 20. 2, 4, 6. Okay, so this is 20. Now, what is my slope? Negative 7 over 1. So remember, we counted these by twos, right? So we have to go down 7. 2, 4, 6. Then the 7's going to be halfway. And then over 1, which is going to be halfway. Ooh. Then let's do it again. So we're going to go down 7. So there's 1. Then that's going to be 3, 5, 7, and then over 1 would be right here.
I'm lost. You are? Good. I'm
You just have to remember that you're counting by 2s. So in each of these, there's another segment in the middle. Now let's go back and graph the first one over here. So y equals 3x plus 10. Remember, we were counting by 2s. 2, 4, 6, 8, 10. Right here. And then what's our slope? Up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And then let's connect these. Okay, where does it look like this crosses? Like right in here, huh? Like at the point 1, 13. And I'm kind of questioning that a little bit. Is that really where it's crossing? Because it's hard to see a little bit, right? But I think that's where it is. So now is where this checking this algebraically comes in. Okay? So now we want to check the point 113 algebraically. So plug the point 113 in there into both equations, and let's see if it works. That'll tell us if it actually is that point where they cross, if that's the solution. We should be writing this down in our notes. So we have something to look back at. Okay, so it did end up to be the same, right?
Yes.
So part of your assignment today is going to be to graph and then check it algebraically. So you'll have your graph on graph paper, and then you'll be checking by plugging them in.